Now let's talk about connecting a laptop to a SyncRite Plus. Here I have a standard USB cable, which I'll connect to my laptop. We'll connect the other end to the USB connection on top of the SyncRite Plus. Once the connection is made, immediately you should see the blue LED on the SyncRite Plus light up. That tells you that we don't have a problem with the power supply or other hardware problem within the SyncRite. Now we can set the SyncRite down and get to work communicating with the device. I'll open my Sync Field Service program, which is the most advanced communication tool and the one you should use. Then we'll open the port and we'll immediately see that the synchronization settings, slip time, and voltage sync populate. This means that we know we've communicated properly. Now we can go into data records and we see we've got 29 records starting with 0 for a total of 30. If we click on Get PUPD, which means power up, power down time, we have a whole bunch of times. Note that these are set for United States Central Standard Time, the time zone in Minneapolis, just in case the field visit you're at has a different time zone. I can see that one of my entries has an asterisk or a star just to the left. In this case, data entry 0. That'll be my most recent data entry. So if I click on it and then click Get Data Set, you can see down at the bottom an indicator moves to the right showing that I'm pulling that data set in. Then if we click on Starts Plot, we can see some data. Now here's a good example of what actually looks like garbage data. We see a bunch of square waves up and down and a bunch of sort of binary information in the bottom. This is actually the result of using the universal tester on the SyncRite Plus. Keep in mind that every time you use the universal tester on a SyncRite, you create approximately 8 data sets, which are not real motor starts, but the SyncRite is powered up, so it captures one data set. Back on the main tab, you can see 2 other important pieces of information. The SyncRite address, which is the unique identifier for the SyncRite device, and then the remote address. This is the address of a wireless panel that the SyncRite would be attempting to communicate with. So if you're setting up a customer with a new wireless display panel, this is where you would enter the panel's address so that the SyncRite is expecting to communicate with it. These are the basic fields that you'll need to use when working with a communication tool on the SyncRite Plus. Now let's take a look at a typical motor start using the SyncFetch software. We've already downloaded the start and opened it, and now we're going to view the different parameters. At the top, we can see the AC voltage, which is induced in the rotor during the startup. When a breaker first closes on a motor, there's no rotation. So there's a 60 Hertz frequency induced into the rotor, and that's what we see here. Then you can see that the frequency decreases as the rotor accelerates to full speed. Once the rotor gets to approximately 95% of speed, we see a gate pulse, and that's this gate down here on the bottom floor. We see the red, which is the sync, telling us that the SCR1 has fired, but in this case, it actually fails to synchronize. The reason being is that this is a large reciprocating compressor, which is notoriously difficult to synchronize, as the cylinders provide an asymmetric torque profile. This is in comparison to a fan or other device, which is very uniform. In this case, the unit fails to synchronize. The field discharge resistors, which are shown as FDR on this blue line, go back into the circuit. It attempts to synchronize again, and then down here at approximately 3.9 seconds, we see finally that the resistors come out of the circuit, the gate pulse is fired, and the unit synchronizes. There's nothing wrong with this synchronization profile. It is simply a requirement of the reciprocating compressor application that the unit needs a couple of pulses to synchronize. This is one of the unique benefits of the SyncRite Plus, which is that it will continue to fire pulses until the unit finally trips out. Now, there are a bunch of diagnostic tools we have at our disposal here. The fact that we see the gate pulse means that the unit did indeed come up to 95% speed. If we didn't see these gate pulses, then there's a high likelihood that the unit has not come up to speed, and we probably have some loading, which is preventing the unit from accelerating correctly. If we see the gate pulses, but we don't see the synchronization go from a 0 to a 1 state, we have to consider that the SCR1 may have failed, because this change of state basically means that the SCR1 has no voltage across it. So if we see a gate pulse, but no change in the SCR1, SCR1 is likely to have failed. If the field discharge resistors are not coming out of the circuit, which is shown by a change from a 1 to a 0, there's a strong possibility we have a problem with the Rite filter or the SCR2, as if the resistors stay in the circuit, they'll eventually overheat and burn. So these are the most basic troubleshooting steps you can take by reviewing a start data from the Rite Plus.